know that we've bought Hazeland. We bought Hazeland last August, and of course the Hazeland actually fronts the River Marden, which tips into the Avon down at Chippenham. But we hope on the cusp of starting off our second purchase, which I can't tell you exactly where it is yet, but we're all very excited. And again, you know, sort of our objective is to really make an impact on water quality, natural flood management, as well as the carbon, biodiversity and public amenity space. So thank you very much for coming along and taking an interest in supporting us as you have done. I can still see people coming in, so I'm reluctant to introduce our speakers for a second until everybody's in. Can I just remind you quickly that we will be filming this event, so if you really don't want any chance of appearing on film during the questions at the end, please do hide your image, and also of course keep yourself mute during the event so that there's no background noise coming into to everybody else's home. That's great. So I think at the moment I'll leave it at that. And have our incomers slowed down, Susan? I think they have.
I think that's everyone in who was waiting, so we're good.
Great. Okay. Yeah. Okay, well, that's wonderful. And thank you again for coming. So I'm going to introduce our two speakers. We've got Harriet Alvis, who's one of our own trustees, in fact, at Avon Needs Trees. She's an aquatic ecologist, used to work for the Bristol Avon Rivers Trust, but now works for West Wales River Trust, and is editor of that magazine that I'm sure you all have on your coffee table, Fish. And so Harriet's going to start off with a sort of a 20-minute chat really about fish life, which I think I can honestly say I suspect most of us probably don't know enough about, and we should do, about this this particular species, this area. And then we're going to go on to Dr Mark Everard, who's Associate Professor of Ecosystem Services at UWE, also a consultant, broadcaster and author, and I'm told all-round expert on friends of fish. Everything else that lives around fish and friends of fish, everything else that lives around our river system. So I'm hoping that I'm sure we're going to get a really interesting overview of exactly what's happening in our rivers, the kind of bits that certainly people like me just don't know enough about. So I'm certainly looking forward to it. So Harriet, do you want to start off and share your slides?
So I'm Harriet Alvis, as I've been introduced, but I'm trustee for Avon Needs Trees and currently working for West Wales Rivers Trust. So my main sort of focus is on river restoration, but also have a big interest in fish as well. So a little bit on the River Marden. It's what we do. We try, when I work for Bristol Avon Rivers Trust, try to class it as a chalk stream habitat. It does rise up in chalk up near Calstone, but a lot of it doesn't actually doesn't actually flow through chalk, but we try to make it a posh chalk stream. It's got an abundance of wildlife, which you'll hear about this evening, hopefully, but it is suffering. It's failing to achieve good status underneath the Water Framework Directive, which is getting a score of moderate for. So it's failing for phosphates, which can come from pollution sources. The river is a key amenity for Carn and the surrounding villages, but also, as Robert from Friends of the Marden Valley will know, it's a key responsibility for the town as well to look after. So I'm going to do a whistle stop tour of the fish species that are present within the river, and there's quite a few of them, and I could talk about them for hours, so it will be quite brief. But I'm going to start with one of my favourite ones, the European eel, just because they have such an incredible life cycle. So the European eel is thought to spawn in the Sargasso Sea, although perhaps the most interesting thing about it is that we don't actually know that for definite. So no one's actually observed them spawning. We haven't actually found the eggs before or seen them mating. So what has been done with research is that they've caught them in the sea and managed to track them down smaller and smaller size, getting towards a certain area in the Sargasso Sea, and they presume that's where they are then born. So the European eel hatches out from the eggs into what's known as a leptocephali, which is the image on the left-hand side here. So it's sort of transparent, as you can see, almost like leaf shape to the eel. And what that means is that it drifts across the sea in the currents, and it will drift all the way over to Europe from the Sargasso Sea, so a hell of a journey. And that can take anywhere sort of up to sort of 2 years, so a longer process. Once it starts getting towards fresh water, it senses that and it starts to change its shape, because at the moment, at this stage, it can't swim actively, it just floats in the current. So it goes to what's known as a glass eel. They're still transparent, but over time, they, as they start to feed, they become pigmented in a darker colour, which is more useful for camouflage within rivers. So they've got more of the characteristic eel shape at this stage. Once they pigment and they keep on feeding, they get larger and larger, and they can sort of reach sizes of up to over 1 metre. The females are usually a lot larger than the males, and they tend to go further up the river to the higher points, just to be able to get the outcompete others for food and get bigger, so that they can make the journey afterwards all the way back to Sargasso Sea. So on the way back to the sea, they have to actively swim, which can take sort of 6+ months. So they've got a hell of a life cycle to them. One of the most impressive ones, I think, of the animal kingdom, and probably why they're such a popular species, despite people often not liking their looks. The oldest known eel was thought to be just under 150 years old, and that was known because it was kept in a well its whole life. So they knew what kind of age it was when they put it in and what age it was when it died, which is absolutely amazing to think that they can live sort of longer than people can. The next species that is common in the Marden is the brown trout. These like to live in the sort of faster flowing, shallower areas of the river where there's some deep pools for them to hide out into. Brown trout are amazing because they are one of the most genetically diverse species in the whole animal kingdom, even more diverse than humans, it's thought. And they are really sensitive to water quality. So they only spawn in gravels that are nice and clean, so not a lot of sediment in them and not a lot of water quality issues. And they will dig out what's known as a red within sort of fine gravels within the river. And that will be, you can observe that when you walk along as a clear sort of circle where it looks cleaner than the surrounding gravel. They'll lay their eggs in there, and those eggs will then hatch out to the picture on the right. And they have this yolk sac on them, which is this big orange sort of shape, and they will live off that until they're old enough to actively swim and feed. So one of the main sort of pressures on brown trout is the any sort of excess sediment or pollution that gets into the river and can clog up those gravels, because it can affect the ability of those offspring to breathe. Things like sedimentation can also impact on invertebrates that live in the gravel and smother those too, and that's a key issue for brown trout because they feed on invertebrates that hatch out from the gravels. So often in about May time, you can see river invertebrates known as mayfly coming up to the surface of the water, and you'll see brown trout coming and actively rising to catch those as they fly off the surface. So that's an amazing thing to look out for. About not long from now, actually. The next one I'm going to talk about is the roach. So the roach is more it is present in the Marden as well, but in sort of a different habitat to you'd find the brown trout. So the deeper, more canal-like sections of the Marden. So in particular, where you've got the big weir at Hazelland, they are pretty common behind there. Deeper, sort of slow-flowing, less oxygenated water. So roach are a shoaling fish. They are kind of characterized by their silver color with the orange fins. They can live anywhere sort of up to 14 or so years, so still quite a long time. They're often confused with another similar fish called the rudd, but the rudd is sort of, you can tell the difference because the rudd have a mouth shape that faces sort of more upwards than the roach. The common bullhead hopefully is one that lots of people will be able to identify just from playing in the river as children. It's often the one that's observed when you pick up rocks in the riverbed. So it's also known as other names such as the miller's thumb, but it's called, named after the bullhead because of its large head, which can take up to sort of 25% of its body length. So they've got a really, really big head. They're really territorial. They live in large gaps between the riverbed sort of rocks, and they're known to be cannibalistic as well. And if any sort of fish tries to take over their space in the rocks, they will try and attack them. So the picture on the right, just to explain that one, where we did an experiment looking at refuge preference for the common bullhead using Lego, just because it's a really good way of quantifying what kind of refuge they prefer underneath the rocks, so what kind of size, colour, and whether it's open or closed ended. So we had about 100 bullheads in tanks for a brief period of time, and identified that all fish, regardless of bullheads, regardless of their size, preferred the larger refuges that were open at both ends and a darker colour. So we're helping to sort of look there at what kind of conservation measures we could put in place for loss of gravels within river systems. But it kind of also showed us just how territorial they can be, and cannibalistic actually. So moving on to the chub, again, like the roach, kind of found in the slower flowing water than perhaps the brown trout and the bullhead. They also shoal in large groups, and they're characterized by their rounded body and their very large mouth. They can live up to 20 years. And yeah, they're a brilliant fish to see as well. That you often see them from bridges when you look over in large groups. Stickleback, they are, everyone's kind of heard of a stickleback. They're very common, but I think they're completely an underrated fish. The males in particular are brilliantly coloured. The females not so much, not as exciting. The one on the right was actually caught on the Marden during a kick sample. You can see the sort of the bright blues of the back and the red underbelly. The males do a really great sort of zigzag dance in the margins of rivers to try and lure the female in to breed with them. And once they've done that, they actually kick the female out and then raise the eggs themselves until they're sort of old enough to swim themselves. So kind of like really, really beautiful fish actually. The lamprey, we've got brook lamprey within the Marden. The picture on the right is actually a sea lamprey, but it's I just wanted to show you the great sort of jaw they've got. Lamprey are one of the oldest vertebrate species in the world. They're kind of like it's similar to an eel in shape, but rather than having the fins, they've got this jaw. They've got a sucker instead of a jawed mouth, and they've got these breathing holes on the side of their bodies. They've got 7 of them along there. The sea lamprey are much bigger than the brook lamprey, and they use these jaws to attach to dolphins and other large mammals within the sea and sort of parasitize off of those. So we're going to cover some of the things that affect our fish in all rivers, but including the Marden, a lot of these examples. So the habitat degradation is one of the main things that we see quite often. So an example of this is the first picture here on the left-hand side at the top. That's actually an example from the Bristol Avon catchment, so not too far from the Marden. So hopefully you can see that the existing river is straightened along the side of the road here, and this line, sort of wet lying ground in the field, is where the river used to go. So effectively, the land's been drained and it's been straightened to the edge of the road. And what that means is you lose that much habitat length, which is obviously quite significant, but you also lose the diverse flow patterns that exist in a meandering channel that's well connected to the floodplain. So instead, in the straightened channel, you get one laminar type of flow that's often fast flowing and can wash out any important gravels or any reds, the brown trout nest, for example. So that's one of the main things that we see. Barriers are also an issue. So I've got a picture at the bottom right here. That's actually of a salmon going up a weir. So we don't have salmon in the Marden, but it is important to show that these barriers are issues for fish movement, and not just the salmon and the sea trout that we often think of as migratory fish, and the eels, but also for any sort of fish species which live within the river, because they all need to move to get access different feeding zones and refuges and that kind of thing. So not only are they a barrier to fish movement, but they're also upstream of weirs, you often see that the water is slower flowing. And what that means is that it doesn't have the same amount of oxygenation because it's not moving as much. And you also get the sediments entering the river and not being able to be flushed downstream. They just accumulate on the gravel, so it smothers all life within the gravels. Water quality is a big issue. I don't know if anyone managed to see the Panorama documentary last night on sewage pollution. That's definitely an issue for the Marden and other rivers, but we also have issues with agriculture, so soil loss and inputs of chemicals entering, livestock poaching on bank sides, and also more urban issues such as point pollution from factories or runoff from any sort of impermeable surface in a town centre. So things like washing your car on the side of the road, that then enters the storm drains, which goes directly into the river. So there's several different sources of pollution that can enter our rivers. Marine issues, particularly an issue for species such as the European eel, salmon and sea trout, which move between the sea and rivers. So often declines in those sort of fish species are directly sort of due to issues in the sea, potentially, rather than in the rivers. And then obviously climate change is a big one. So change in the ocean currents affecting movement of fish. For example, the eel drifting across on currents, clearly going to be affected by any change in those. So on like a more positive note, what kind of things can we do and what do we do within the Rivers Trust movement? So I showed you that straightened channel earlier on. A thing we do like fairly often is looking at river restoration. So we try and take the river channel back to the route that it originally took. So rather than having the straightened channel, we look at LiDAR imagery and other satellite imagery to look at where the river used to go. And where we can, we try and redig that channel and let the river flow where it wants to go. And also reconnect that with the existing, with the adjacent floodplain, because that's really important habitat for things like fish escaping fast flows during spate flows in winter. Where we can't do that, because often it's not possible due to development either side or land being used for agriculture, we will put in structures into this straightened channel. So we will try and put in what's called large woody material or woody debris sometimes. So basically hinge trees into the channel, which creates sort of diversity within the straightened new channel. So anything we can do to try and create more diverse flows, habitats, depths, that kind of thing, to recreate what used to be there. The other issue we often see as well is this the straightening is over widening, which can have issues for sort of water levels. And the other thing is insize bank side. So where rivers are put into a steep channel, so they dig them deeper or they put walls either side. I think most people nowadays, if you said to them, can you draw me a river system, they would probably do a fairly straight line, if not some sort of meander. But actually, originally, a lot of rivers would have been multi-channel systems rather than just the one single channel. And our perception of them now is a lot different to what they used to be. And we've lost all that habitat with it. So the other thing we do is weir removal. And this is something that is relatively easy to do. It's just the paperwork before it, which can take the time. This is one we did about 4 months ago. This wasn't actually in the Bristol Avon catchment, but it was over in Wales. This was 6 years worth of paperwork for a day's worth of weir removal. But it's opened up this channel, allowed it to flow naturally, allow fish to go up to sort of about 20 kilometres of upstream habitat, and resulted in a lot cleaner gravels. And hopefully, if ever pollution does exist in that channel, it will just flush down and dilute a lot quicker than being trapped behind a weir. So that's what we try and aim for with barriers. Sometimes it's not possible because the weir can't be removed due to localized development, which might increase erosion risk. So in those situations, we will put in what's known as a fish pass or a fish ladder, some sort of way to enable certain fish species to navigate that barrier and reach the upstream habitat. The other thing we are really keen on doing is looking at buffer strips, and these are effectively trying to exclude livestock from the river channel to enable vegetation to grow either side of the banks, to stabilise them and to provide cover, which is increasingly important as the rivers get warmer due to climate change. This is probably the best example of a buffer strip that we've done so far. This was basically a bare channel before, eroding bank sides where livestock were getting in, no vegetation growing either side. Fenced off 15 years ago, and now it's a lot more diverse, there's a lot more shade and a lot less nutrient inputs getting in to the channel. So this is what we try and aim for, and ideally this would be along all rivers in my eyes, and some sort of footpath along those too, to allow people to get along the river and see the beauty of them and sort of engage with their environment. The other thing we look at increasingly often nowadays is what's known as sustainable urban drainage. So this diagram just shows the difference in where water goes when areas have been urbanized. So when you put impermeable surfaces down, such as roofing, concrete, tarmac, that kind of thing, what happens is the water all rushes off really quickly and goes down the storm drains and directly into the river. And what that means is it takes with it a lot of the pollution, but it also increases flooding downstream as well, because the water doesn't have time to sort of soak into the ground. So we try and put in a series of interventions. So these are sustainable urban drainage ideas. Things like swales, which are basically water storage strips, filter strips, so just where vegetation allows the water to sort of slow down before it reaches the main channel. Detention ponds, which are good in some cases, but obviously need to be, it needs to be dredged out every so often because they accumulate silt, so they need maintenance. Wetlands are our main sort of interest, because reconnecting a river to the floodplain allows for a lot more sort of natural processes to occur, and species like eels absolutely love those for sort of nutrient-rich feeding zones as well. And then things like pervious pavements, where the pavement actually allows water to soak in, reducing peak flows. So sort of ways you can help. We've got a link on the Rivers Trust website to find your local Rivers Trust. Bristol Avon Rivers Trust cover the Marden and nearby rivers, so they are always looking for volunteers to help with projects and donations as well, because they're a charity. If you're interested in finding out more about the health of your local river, they've got a really good website link where you can zoom in onto the map and look for your local one to see the water quality status, but also the fish that have been caught by the Environment Agency on those sites. A big increasing issue at the moment is misconnections. So that is when a house is incorrectly piped into the surface water network rather than the foul sewer network. So the surface water one goes directly into the local river, whereas the foul sewer one gets treated under most conditions. So if you could check for misconnections, that's brilliant. All the conditions of a septic tank, because they always need maintenance to make sure they're not leaking. Convincing people to leave space for wildlife along rivers. So things like councils are often quite keen to cut down any vegetation alongside the river, reducing the cover and sort of increasing erosion, that kind of thing. And also people with livestock to fence them out of the watercourse. One thing we do quite a lot is put in solar powered pumps, which enable animals to get water out the river without them having to go in. And that's also got benefits for livestock health as well. There's certain conditions that are bacteria and things that are sent down rivers. And then the final plug is, if you're interested in fisheries, to join the Institute of Fisheries Management, which helps to protect future fisheries and look at how we can better improve management of all our fisheries. And also you'll receive our quarterly fish magazine, which I've heard is very good. So yeah, I thought I'd end on a fish pun, but thank you very much for listening. And I'll be here to answer questions, I think, after Mark's talk, right?
Great. Thank you very much, Harriet. That's really good, really informative. Can I add one extra bit in there? I don't know if anybody has or hasn't seen the documentary Seaspiracy, which is on Netflix at the moment, but personally, the issue about overfishing, I think it really addresses well. It's a very good documentary. Okay, so Mark, can we come over to you now? Are you ready with your slides?
I can, yes. I'll share my screen. I think Harriet needs to unshare it first.
I've clicked it, so hopefully it will happen in a minute.
Yeah. Okay, so rock and roll. How is that? Can people see that?
Yes, that looks good. We've got your sidebar as well at the moment.
Yeah, I'm trying to get it to play the game. There we go.
Good.
Just lose that a little bit. Good. Okay. Well, I'll try and keep it to about 20 minutes. I've changed the title a bit: Fish and Their Friends and Enemies. So more on that. Fish's friends don't just include living things, because fish are part of living catchments. And in any catchment, the first forces are physical: where the water falls, how rapidly it comes off the landscape, how it moves through the ground. And the second set of forces are chemical, the natural as well as the man-made chemicals that come into the water. And that determines the ecology. And fish live in a complex of ecology with plenty of feedback loops. So we need to understand all of those links. And then that determines what we can do with it, the socio-economic potential. And here's Quemmerford Mill, an old photo I found on the internet. But these are completely interactive systems. Each factor drives the next, and everything we do changes it. So the mill would change the physical forces in the river. The effluent from the mill would change the chemistry. The backed up flow would mean that there would be different plants above and below the mill that would support different invertebrates, different fish, different mammals, and so forth. So it's not just what lives there. And of course, that shapes the rivers very much. Now, there's all sorts of classification schemes of rivers. And this one used to be, Marcel Huet's classification used to be flavor of the month in the early part of the second half of last century. And basically, under the classification, rivers were classified according to the turbulent zones where fish couldn't exist because it was too flashy. Then the trout zone, Harriet showed us some trout. As flows went down a little bit, the grayling zone, another member of the trout and salmon family, but not quite as adept at the turbulent waters as the brown trout. And the barbel zone, a nice streamlined fish, nice strong flows. And then below that, the bream zone, these fish that have a body profile a bit like a dustbin lid that need to live in slack or slow flowing waters. They couldn't live where the trout live. The classification is not really used anymore, but the basic principle that there are some fish adapted to fast flows and some to slow conditions still is true. It's just that in the Marden, well, spot me a turbulent mountain river in the headwaters. I certainly have never found one there. We impound rivers all the way down their line. So we actually punctuate them. We create fast water below the weir and slack water above it. So if we go back to Marcel Huet, we might find the bream and the roach above the weir and the trout and the grayling below. Ask a fisherman, they'll tell you that's where they are. But of course, we've vastly disconnected the rivers from the living landscapes. They don't follow down those lovely old sinuous channels that we saw in Harriet's photos, because we've dredged and drained the land for food production, for infrastructure, for settlement. So we've radically changed the rivers. And of course, a barbel zone, well, you need to have barbel present. And the natural range of the barbel, like many, many fish species in the UK, is actually related to the Doggerland Bridge before the last ice age, when the British Isles were a peninsula of continental Europe. And the Thames joined the Schelde and the Rhine to form the Channel River, now the English Channel. And that explains why many, many fish species have a native range to the east there, but not to the west. So not only would we not have a barbel zone on the Marden and the Bristol Avon, we wouldn't naturally have barbel anywhere outside of that envelope. So things are very complicated. I'm just going to move into talking about some of the living things, because autotrophs, it's a name of things that photosynthesize. That's where the productivity starts. And we're talking various forms of algae in the plankton floating in the water, the Aufwuchs, which is a German term for the attached algae, the filamentous algae, and the water plants. This is a hornwater, a Ceratophyllum demersum. It looks like a rooted plant, but it's in fact an alga. And we have various rooted plants, those that are submerged, those with floating leaves, those that are free floating on the surface, and those that emerge out of the water. All of them you'll find on the Marden at one time or another. They're all producing organic matter that feeds the river ecosystem. And then, of course, that primary productivity is largely converted up food webs by heterotrophs, invertebrates. We tend to think of invertebrates in different feeding guilds. There are those that shred organic matter, chomp it up, rotting leaves and whatever, like this Plecopteran or stonefly. There are those that collect it from the water as it goes by. You'll find plenty of these simulium, for example, in the Hazel and Weir, where there's very, very turbulent water coming down. They like turbulent water without predators. And what they do is they put a silk pad on a hard surface. They've got hooks on their bums, and they hook their bums into the silk pad, and they wave their heads around, filtering particles from the water. There's various groups of invertebrates do that. Others, like the snails, graze on rocks, and imaginatively they're called grazers, whilst others, like this beetle larva, as well as some dragonfly larvae, are voracious predators. So in and around where the fish live, the plants are producing organic matter, the invertebrates and other groups of organisms are converting it up the food chain, and then we have the fish. But of course, some of the fish are friends and some aren't friends. Some of the fish are predators. All of these species you get in the Marden. The pike, sometimes known as the freshwater shark, certainly you get them in the Marden. They are an explosive ambush predator. They can grow up to about 4 foot long, even in your river. I've caught them in the Bristol Avon about that size. The perch is this bold striped fish that tends to hunt more as a pack and tends to be more of a pursuit predator. It tends to chase things down rather than lunge from cover like the pike does. And then the chub, it's got this big wide mouth and they kind of eat everything. They're not too fussy. Harriet again showed us pictures of chub. Other things that eat fish in the river commonly, the kingfisher, the grey heron, both native species, I'm sure we've all seen them, and the cormorant, which since the 1970s has really moved inland. I mean, when I was a kid, you didn't see cormorants inland, but what we've done is we've decimated the coastal seas by overfishing them, and we've created inland seas called gravel pits, and so wholesale the cormorant population has moved inland. And particularly when the bigger still waters freeze over, they fan out and can often hunt in packs on small streams that don't freeze over, and that can have quite a devastating effect. And then, of course, we have the other predators of fish, the otter. I see plenty of otter where I am. I live in Great Somerford, so I'm close to the river, and I have a habit of lurking by rivers into dusk. Bit creepy, but it's because I'm fishing, honest. So I tend to see a lot of otter because they're crepuscular, dawn and dusk feeders. I'm sure you've got them on the Marden. I don't spend enough time there to have seen them. And there's various other predators. We've looked at the invertebrate predators like this dragonfly larva on the right, but also not on the Marden, not in this part of the world, the fen-raft spider, spiders that hunt small fish. So it's a hazardous life being a fish. So yeah, there we have it. We have the sun, and we have plants that collect and convert to organic matter, feeding the invertebrates that feed along the food chain, the fish, their predators. not all productivity in the river is from the river. In fact, productivity that happens in the river is known as autochthonous productivity. Don't worry about the big name, but a huge amount of food in rivers actually originates from outside the river channel. So there's a tree. We had to have trees, didn't we? But as a really important organic input to rivers. That seems to be the case in nutrient poor rivers, but also habitat poor rivers. And let's not forget that all of our rivers in one way or another are pretty decimated from a habitat point of view. Every fish has important functions. We've met the bullhead in the middle there on Harriet's presentation, the stickleback at the bottom, and the minnow that was that you have to let me know what you think about that. Fishy pun there. But there are many other organisms inside and outside the river system, including a vast load of microbes that keep the whole ecosystem turning. These are all vital for the fish. And if we just try to manage the fish without managing the whole, then we can't succeed. I'm just going to look at the life cycle of the roach. I'm pretty obsessed with roach. I've written 2 books on roach. But it does illustrate the dependence of the fish on a multiplicity of habitats and food types. This is the roach, Rutilus rutilus, member of the carp family. And let's start with the life cycle with spawning on vegetation, anytime from about now through till May, typically. I've mentioned June because further north that might be the case, although round here, late April, exceptionally into May. They spawn communally on vegetation, be that submerged vegetation or the underwater stems of marginal emergent vegetation. They're tiny. The eggs hatch out into a form of larva which has incomplete fins, incomplete gut, still attached to a yolk sac, and they stick onto vegetation, and they might stick there for a few days, 4 to 10 days or so, and then they emerge as free swimming. Well, they're really just the size of an eyelash. So absolutely vital that they've got good food-rich habitat without flows that they just simply can't resist. So again, you know, we're going to keep coming back to the importance of the right type of habitat. That's a pin in this photo, and these are larvae of, actually they're larvae of dace, but the roach larvae are pretty similar. But they can grow as much as 1/3 of their body weight per day during their first summer. So they go from these tiny little larvae, tiny vulnerable larvae, so that by the end of the autumn, they are more fully developed and able to swim freely. As the roach grow, well, it's interesting, they kind of grow really slowly, and after about the age of 3, the growth accelerates massively. And that's because suddenly their mouths are big enough to eat much more protein-rich foods, like this water snail. It's known as a gape-limited diet. Suddenly the larder door is open to them, so the growth rate accelerates massively. But the roach is the ultimate omnivore and generalist, and will eat any of a range of plant, invertebrate, even other fish, egg, and small fry food. The ultimate opportunist, and it changes its diet according to availability throughout the year, including detritus, organic matter rich in microorganisms. This is not a tree ring. This is a roach scale, because roach grow through their lifetimes and accrete more material on the outside of the scale. So very much like tree rings, you can read more or less the seasonality. This roach, you can tell, was 13 years old, one of the oldest roach I've ever actually counted myself in terms of age. And then they reach the age of about 3 years, exceptionally 2 years, and they're back to their mucky stuff on the aquatic vegetation. And they'll be doing that more or less, preparing for that this time of year. Now, the life cycle is an interesting one when we look at the vulnerabilities, because there's a barbel on the bottom and a roach at the top. The roach spawn on the plants, the barbel on the gravel, and they lay eggs of different sizes. Whoops. that give rise to these larvae with attached yolk sacs. And by the end of the year, the roach are about 17 millimeters, 1.7 centimeters, less than an inch long. And by then they have developed fully their fins and their guts, but they need to be strong enough to withstand winter spates. And that's a critical thing. And then after 2, 3, 4 years, they can join the spawning population. But there is a double whammy, because if you get, using this barbel as an example, if you get a really, really cold winter, the fish won't be feeding well, and there won't be much food around for them to put down rich yolk reserves. That's a chicken's yolk, I know, but you know what a yolk looks like. So the eggs that are laid are very low in yolk content, and so the fry that hatch out, or the juveniles that hatch out, are weak and small, and they don't get that leg up to grow the following summer. And if we have a cold summer, then we might have a paucity of the algae that they generally eat first, and then the water fleas and the bloodworms, the various range of invertebrates that they need to grow on, so that when they reach the end of that first year, they can withstand those heavy spates of autumn and winter. And as fish like a barbel in the UK, pretty much at the north of its geographical range, most years the spawnings will fail because the fish just can't withstand that. Chub in particular have very, very clumped age distributions in a population. You can find some that are 18 inches long, some that are 6 inches long, and not a lot else. And you can track them back to good, stable, hot summers like the one we had last year, which will be good for the recruitment of those fish. But in other years, they might just get all washed out in the winter. And then the roach can continue to grow on exceptionally to 15 years. I've never counted one more than 13 years, but they can get much bigger and older. And they're tough. I mean, this is a deformed roach that managed to live in the river, I think that one for about 10 or 12 years. And they're pretty tough and widely distributed. Mainly live on the bed, but this one is cruising with a chub at the surface. In the hot weather, they'll come up and eat off the surface. And they've got significant economic and cultural values as an iconic type of fish of lowland rivers, with a major angling industry associated with them. Sweeping up towards the end, I've got a lot more slides, but I'll try and accelerate through relevant ones. We are used to the idea of rivers looking like this, lovely natural river, a bit of the Bristol Avon. This is another river I work on called the Brahmaputra in this is Assam, Arunachal Pradesh, northeast India, and it takes a couple of hours to cross on a rickety old boat, and you really do need to believe in reincarnation when you do that with a big 4x4 on a very narrow wooden boat. You can see it's braided, lots and lots of channels that constantly change every year with the monsoons. Now, very different rivers, but our rivers would have been like that. They would have had open areas, new channels, a tree would fall, that would block a channel, a new channel would scour, the aurochs or the precursors of modern day cattle would graze and clear a bit of plain there. We'd have hugely diverse channels. But of course, the rivers we're used to, the Thames here used to be a mile wide in Roman times. The Romans settled here because you could bring a big boat up, but still cross the river by ford and footbridge, and you could get your waterfowl and your water and your grazing and your fish, had everything you needed. But now we've turned it into this channel of muddy water between concrete banks that swirls up and down twice a day. And this is a World Heritage Site, as we know, and yet weirs are anathema to natural process in rivers. So we've grown up with this idea of what rivers look like. And this is, the Haywain is probably the best known river painting. And in our psyche, this is a natural river. But from a river scientist point of view, it is so trashed. It's disconnected from its floodplain. There's erosion on the bank. There's navigation structures. There's animal trampling. The bank on the near side is trampled to bits. There's a building on the edge of the thing, on the edge of the channel, and a mill, and there's even a truck in the middle of the river. So we have this psychology of a river, the way we think natural means, that actually is very unnatural. So let's go back to our little stretch of the Bristol Avon here. The landscape has been wholesale drained. We have lost the sequence of wetlands from the river channel across an active floodplain of meandering channels with fens and marshes and backwaters and all the rest of it. We release effluent, we abstract water and change the flow, we impound it. We have invasive alien species like this signal crayfish and the Himalayan balsam. We have natural predators. We have predators that we've introduced inland. So we have less resilient rivers. So when we have the recovery of natural predators, the river is just less resilient. I'm a big fan of otters. Not all anglers are, but I haven't worked for 30 odd years for otter recovery, then to suddenly decide I don't like them because they eat fish. That's what they do. So here's an interesting little piece of habitat. Now I tend to call it the 3 Fs, and I won't tell you exactly what they stand for, but it's basically feeding, flight, and reproduction. When you look at a river, where is the food for all of these different life stages? If we remember our roach life cycle, where is refuge from spates, predation, and other threats, and where is the reproductive habitat? Where will they spawn? Where will the juveniles subsist? So it's a little picture of a bit of the Bristol Avon with a nice sallow bush dipping in. The river flows from right to left. You can see it's got nice slack flow downstream. So you've got yellow water lily beds, really nice little bit of habitat. And yet close by, this has virtually no feeding, refuge, breeding habitat of any use to fish at all. And yet a lot of our rivers are trampled this badly or worse. A fish has nowhere to evade strong currents and predators, quite apart from breeding and feeding. So what does being a friend to the river mean? Well, Harriet's covered a lot of this. This buffer zone that we put in, a good time ago, before Harriet worked for the Bristol Avon Rivers Trust, that's now virtually mature forest on the right bank there. The great big tall willows all the way down. So the habitat diversity is massive. It used to be 330 meters of moonscape, just mashed clay all the way down. So that's done a lot for the feeding, the refuge, and the reproduction needs of the fish. Buffer zones, do they work? Here's my submersible camera, one side of the fence, and here it is the other. You can see the fish are quite happy to be near me because they've got the refuge and everything. But on the mashed clay, 10 yards away, no use whatsoever. We need to put buffer zones between arable as well as livestock and the waters. We can do other things like live willow deflectors. I'll go through this really quickly because I think we need to move on to your questions. Do they work? Here's some live willow deflectors. Here's a spate in winter. Without the deflectors, these little guys would be washed out. As it is, they're just chilling out in the lee behind the deflectors. There are things we can do like dropping willows by half cutting near their bases. That creates wonderful habitat, and we can pin logs to the bed so that water tumbles over and opens the gravel to spawning. Let's just flick through that pretty quickly. Just a little teaser here before I close. When I was working in Colorado, in the Rivers Trust, I helped set up the Rivers Trust. We try to get a bit of money to do a bit of habitat work, and it's difficult and all the rest of it. In Colorado, the rivers look wonderful because they've got beavers in them. They're what's known as ecosystem engineers. The idea of an ecosystem engineer is a species that shapes an ecosystem. So think elephants clearing savanna, stands of water plants that trap sediment and create slow water, wolves, limpets on rocky shores. But the European beaver, we drove it to extinction in the 16th century for hunting it for meat, fur, and castoreum scent glands. But naturally, beavers create a diversity of channels and slack water and scoured areas. In the California, beaver reintroduction is part of a program for steelhead salmon recovery because they diversify the habitat. And yes, they do wonderful things, and they do it 24/7. You don't need to pay for them to do it. And I'm not saying that necessarily we'll get beavers back on the Marden, but it does demonstrate the interdependence of all of these organisms with the habitats within which fish live, and which fish are threatened by if those habitats are impoverished or lost. Yeah, just a couple of resources here if you're interested in fish. This book I wrote with Jack Perks's wonderful photos. I saw Harriet using some of Jack's photos in her presentation, and I wrote a book called River Habitats for Coarse Fish because I saw so many fishing clubs destroying habitat in the name of improving it. There you go, fish and their friends and enemies, and you can make up your mind whether which side of the fence you want to put humans on that one. I'll unshare now, shall I?
Yes, that's great. Thank you, Mark. That's fine. That's lovely. Thank you very much. Thank you to both of you. Yes, that's a good question. Are humans friends or the enemies? I guess we probably end up in the enemy camp, don't we? But anyway, I would like to open it up to questions. So if anybody would like to signal, I haven't seen what's happening in chat, but if anybody would like to signal that they have any questions, please let me know. Susan, can you help me here? I tell you what, or please put any questions in chat if that's easy, if you don't want to show your face at all.
I can see that Bruce has a...
Bruce, yeah.
Yep, okay, we've got one here from Bruce. Yeah, sorry, Bruce McInnes, yeah.
I was just wondering, so I know the Marden's got 2 weirs on it before it even hits the Avon. Is it worth campaigning to remove them for fish benefits, or is it pointless because there's then several weirs all the way down the Avon to the sea?
Mark, did you want to answer this one?
Well, it's just at Hazeland. I don't know how the hell you get a fish past at Hazeland, but over to you, Harriet.
I would say that it's worth doing purely from a habitat value on the Marden as opposed to like a wider fish passage on the Bristol Avon. So we mentioned that it impounds the habitat upstream. I'd say for that reason alone, even taking like disregarding sort of salmon and sea trout, I think it's worth doing just to improve the health of the Marden. And we have seen there's a weir above Castlefields Park and the next park up, I can't remember the name of it now, but we've seen a brown trout trying to get up that before. So yeah, I'd say it's worth doing for the resident fish as well.
And is it easy for public to lobby, or is it not an easy thing to get done? As you said, it took 6 years for the one you showed.
Yeah, the paperwork is quite a process, but it's mainly about getting landowner permission, and then depending on the size of the structure, there's things like flood modelling you've got to do to ensure there's no erosion risk. Hazeland, as Mark said, is a massive challenge, but we are starting conversations on it. Luckily, Hazeland is just above our site, so maybe we can help out with that because yes, we've got the land. So yeah.
Yes. Presumably, Harry, have I got it right? It would. I mean, we're talking. It would cost a few million to take that weir down, would it?
That one, yeah, probably quite. Yeah, for smaller ones, it's nowhere near that. But yeah, I think there's a lot. We've got everything going wrong for it there. You've got the road, you've got houses nearby. And it's an old flood structure, so all of those will add to the difficulty.
Yeah, actually, can I just jump in there, because what I'm interested in, one thing I'm interested in, Harriet, is I remember you mentioning that weirs have a natural life as such, and that weir at Hazeland has gone past its life value. You know, what does that mean exactly?
Yeah, just in terms of the engineering sort of lifespan, so the number of years before, I guess, it needs to be reviewed, either sort of maintained or removed. And I'm not sure if it's the same for all structures, but that one has apparently reached the end of its lifespan for the Environment Agency. So they'll be having to think about it at some point, what they can do with it. It's not, I don't believe it's in use as a flood defence structure anymore, so it's an ongoing cost to them. Okay. But I don't know there's anything happening internally or if it's going to be pushed aside.
Gosh.
Yeah,
What,
I mean,
why-
as I understand it, it was part of the canal sort of engineering, so it goes back centuries, really, and unpicking the rights of people associated historically, you know, with current and future need is a really complicated thing. In theory, under the Water Framework Directive, which is transposed into UK law, so still very relevant, even though we committed suicide from a European point of view, you know, removal of barriers is important ecologically, not just for fish, but for the movement of sediment and chemical processes and all the rest of it. Hazen does present particular challenge because of the size of it, the drop of it. So I'm not quite sure how you would do that. I think the only way there would be a complete channel bypass wiggling around farmland, and then you've got to purchase a farmland and, you know, all the rest of it. But some other work I'm doing on a species reintroduction of a species that we drove to extinction in 1969, the burbot. Really, the reason we lost the burbot, I'm just publishing a book on it, is we destroyed the habitat they need. And that habitat is good interconnected floodplain habitat. And yet all around here, there's maize cropping on the floodplains. And so the market rewards us destroying the floodplain and regards the damage as a unnecessary, you know, an unavoidable externality. And yet conservation is seen as a cost and a constraint. And yet the benefits of conservation are exactly the externalities of the maize growth. So I'm doing a little bit of economic studies around it, just to try and change government thinking about what value means. How do we actually value a natural river or a more naturalized river in policy terms, rather than sort of saying, oh, you know, we need to produce cheap food and forget the future, which is effectively the business norm at the moment.
Wow, good luck with that. That's a massive change of mindset at government level and within society, I guess. But needs to happen. You're right. Robert, did I see you had your hand up?
Yes, I did, Nikki. Thank you. This is just to ask Mark. Mark, you were talking about the beaver in the Colorado River, and then we have the otter in the Marden. Are they equivalents, or is it completely apart? Because you talked about the beaver being the ecological engineer of the Colorado. Does the otter help in any form of engineering on the Marden?
Well, I mean, they are very different animals. The beaver is vegetarian, and it changes the habitat. So it creates refuge habitat for itself and feeding habitat. But they do wonderful river engineering that is good for water quality, that reduces water bills, helps address flood issues because they create a natural buffer or sponge landscape and huge diversity of habitat. The otter is a predator. And it's a predator of fish, amongst other things. If you ever watch otter feed, they're mainly feeding on small fish, actually. People sort of say, oh, they're chasing the barbel and the trout and the salmon. Actually, mainly they don't. Mainly they're eating bullheads. That's all the 3 otter surveys I've been involved with. Their main diet is stone turners. Turn the stone, munch what's underneath it. So eels and whatever. So they are a sort of an engineer. And one of the reasons that we need to welcome them back, apart from the fact we poisoned the hell out of them from the 1950s and nearly drove them to extinction over much of England, is that essentially they got replaced by mink when they became invasive. And we lost our water voles because the mink is the only aquatic predator small enough to get into a water vole burrow. But mink and otter are both mustelids, weasel, badger family, and otters hate mink and tend to drive them out. And, you know, the otter recovery is part of potentially saving the water vole. So they have an engineering role, but very different to the beaver.
Great,
Thank you
very much. Actually, we've got a really nice question here from Phil Smith in the chat box saying, what improvements to the riverside along the Hazeland site could be undertaken? You tell us, what should we be doing at Hazeland? Harriet, do you want to? Yeah, who wants to go first?
I don't mind.
Hey, go on, Harriet. Go for it. Go on, tell us.
I think, in all honesty, there's limited amount of restoration you can do to that site on terms of the river until that weir's gone, because it's basically completely impounded it and it's made it more of a canal than a river. Mark might disagree. There's
No,
you could I don't know, we do add sort of trees to the river to, like, as Mark showed, deflectors to increase sort of diversity and make refuges for juvenile fish, but difficulties with that is that we can't do that close to a big structure like Hazelland Mill, because it could get sort of caught up in the structure and damage it and cause flood issues. So not much in that site specifically, but we have done a lot of other improvements. Bristol Avon Rivers Trust have, along the Marden. So we've done a few weir removals and some sort of tree planting and some in-stream habitat improvements, so adding wood into the river, and also a little bit of fencing. And we've drawn together a whole plan for the whole of the river, thanks to funding from Carn Town Council, for a series of other improvements that Bristol Avon Rivers Trust are still taking forward. So there's lots of different potentials along the river, just maybe not so much in that site.
But also, let's remember that these species are mobile, and most species of fish move upstream to spawn to counteract the tendency to drift downstream. So there's lots of compensatory stuff we can do upstream to improve the recruitment, the breeding success of fish, that then will permeate down to repopulate that stretch. There's always things we can do on the stretch, but let's think in terms of catchment scale to get the whole reach of river better functional.
Right. No, that's a good point. Yeah. Okay. I've got another one here in the chat box. Again, quite specific to Hazeland area, from Matthew Short. Do you have any views on how the road across the river, presented in the future Chippenham plan, and associated 7,500 houses in adjacent fields might impact the river ecosystem? So yes, big developments planned for the area. Have you had a chance to look at how this might impact the rivers, the Marden in particular?
I feel we should get Nick Murray onto this. I see he's in the chat.
Well, I'm sure that there are many things to say about the housing development in all sorts of ways, but just specifically on the impact on the river. I mean, Harriet, you were talking about the pollution that the extra runoff, of course, that comes from urban areas, but also that comes with a lot more pollution, presumably, and that will impact the Marden, I assume. I know you might not have had a chance to look at the plans in detail, but
yeah, any housing development will, largely because of the impermeable surfaces, but also the extra pressure that more development puts on the sewage network. So more dirty water getting into the system through household waste, but also more clean water getting into the same system from the runoff. So then that overwhelms the sewage system and causes more releases through combined sewer overflows. So there's a few of those on the Marden, which I know have been issues in the past, releasing raw sewage in times where there hasn't been heavy rainfall, so they have been inundated and discharging as they shouldn't be. There was a time when in Castlefields Park we were working in the river doing some in-stream woody debris work, and we had to get out because a small bit of rain came, the CSO released, and we were just bombarded with sanitary waste. So there are issues with that with development on the river anyway, and any more would add to that, but that's the same in every catchment pretty much.
Yeah, and Harriet, just to clarify, that's coming from the sewage plant just upstream from Hazeland, is that right?
That one was actually there's a CSO in Carn Centre in Castlefields Park.
Just when you say CSO, you mean
combined sewer overflow? Sorry.
Right. Okay. Right. So a little bit further up. Okay.
Yes.
Okay.
And then partially the issue with that is people flushing sanitary waste as well. So we always say only flush the 3 Ps, so pee, poo and paper, nothing else. But yeah.
Okay. Okay, we've got another question in the chat box there. Are there ways we can encourage water voles at Hazeland along the River Marden? Nikki might already have a plan for this. All I know is that water voles are our fastest declining mammal in the UK, I gather. That's what
Yeah.
I heard last year.
Well,
So
it's good to see
go on, Mark.
apart from anything else. And yeah, I mean, there's many things we can do. Getting rid of the mink is a really big one. I mean, water voles are very prolific. They can repopulate whole rivers really quickly. 7 in a litter, 4, even 5 broods a year. Very much like the kingfisher. You know, they can produce 21 juveniles, 3 broods of 7 in a year. Mainly, that means that they're virtually 21 will die because they're so territorial. But the water vole isn't territorial, but that have the ability to spread and be resilient against starvation and predation and all the rest of it. And the mink has proved to be probably the biggest problem for our native populations. And the other things we can do, I mean, it does sort of tally really with improving habitat at Hazeland. The more off-channel habitat you have, the more functional habitat you have for fish, for invertebrates, for mammals, whatever. And there's evidence that as if mink go through a river system, they don't always fan out to hit the outlying wetland habitats. So diversity of habitats in the floodplain has many benefits, including for water vole. But getting rid of the top predator, the American invasive predator, is probably the single biggest thing we can do.
Okay, but my understanding is that there's no point in now tackling that just at Hazeland unless it's being tackled across the catchment. So unless there's a catchment-wide plan for that, is that right?
Yeah, that is true. It's a bit like the balsam problem. If you can pull all the balsam you like, but if the seeds are coming down from upstream, you kind of, you got to do it anyway. But encouraging otters, as I say, because otters are highly territorial. The main cause of otter mortality is otter on otter deaths. And the main way to control mink is to get the otters to do the job for you. So, encourage the otters, maybe some lethal control of mink where they are locally a problem. But where I live here, I haven't seen a mink here in years, not since the otters came back. So, let nature sort it out, because otter and water vole have coexisted for millennia.
Okay, right. I think we really should be wrapping up about now. We've got one more question in the chat, which I haven't had a chance to read yet. So can we just make this the last one? And I'm really sort of Matthew Short, a philosophical question. Do you have any thoughts on granting the river the rights as a company is granted rights and a legal entity in its own right? I believe this has been done for some lakes around the world and is being possibly considered for the River Frome. It's a new one to me. Would this be feasible for the Marden? Okay, we'll make that the last question. Have you any thoughts about giving rivers a right?
Well, up till this dreadfulness we're living through, a lot of my life was spent in India, and so I'm very interested in the Ganga. The Ganga, Mother Ganga, is a goddess, but the goddess was granted legal rights as a person a few years ago, so that court cases could be fought in court. And we've seen this in New Zealand as well, where rivers have been given the status of a legal person. The problem is the Ganga was completely screwed over as a god, so relegating the god to the person doesn't seem to have made a lot of difference. But we need a different legal system, certainly. We have a rights-based legislative system here, that if I own that field and you live downstream of me, effectively you've got to pay me a subsidy not to ruin the river when it comes down to you. That's kind of the way property law works. And it's a very feudal, really, type of system that we live in. I don't know what the ideal model is. Granting water bodies sort of the status of legal persons, I don't think quite cuts it, but I don't know what the answer is. We need a much more mature approach to to it. I mean, I could talk for quite a long time about this, but I'm going to let Harriet have a crack, because otherwise it's just me waffling.
Harriet, did you want to add in there?
It.
Harriet, you're on mute anyway. Yep.
Sorry, no, that's fine, Mark. I think you covered it. Yeah, I do know that the Freeman and Somerset, they are trying to get that process through. It'd be interesting to see how that works, and if it does work, then something that we can possibly try and get in other rivers too. There are a few issues with sort of rights of the rivers at the moment. So a lot of the time when we have pollution incidents, the fines for them are quite minuscule, and it's almost considered a business cost for some organisations. That's something we'd really like to fix. Sort of placing more value on fish lost and coming up with a system that represents the damage that pollution does cause. But yeah, that's another, I could blabber about for ages as well.
Okay, all right. Well, let's draw this to a close then. I just want to thank both our speakers. We really appreciate the work you put into this evening and your presentations. They've been fantastic. Thank you very much. I think everyone's learned a lot. Robert, as leader of Friends of the Marden Valley, do you just want to give us a little update on what Friends are up to at the moment?
Thank you, Nikki. Yes. Well, thank you, Harriet and Mark. Mark, it's nice to see you for the first time. You were very good on emails, but it's nice to see the face that goes with the emails. Well, on the Friends of the Marden Valley, 3 of us are councillors in Carlton Town Council, and 1 is a councillor on Wiltshire Council, which is very, very big and very important. And he's the leader of the climate. He has a climate change portfolio. What's happened is that we're in election season, so everybody's out and about doing stuff. And people are just talking about elections, nominations, who's going to win, who's going to lose. Fortunately, that'll finish on May the 6th, and we can get back to the normal world. I'm afraid that at present moment, things have been slightly overtaken. We'll have our next Friends of Marden Valley meeting in a week's time. And at that moment, I'd like to put forward plans for the Marden Valley Festival, which will take place on September the 25th. And which I would hope that Avonese Trees and Harriet, maybe Dr Mark, would like to contribute something in a certain way. So yes, there's a bit of a hiatus for us at the moment, but things will start again as from next week.
That's great, lovely. Thanks very much. Okay, well, just one other mention, as I say, with these events now are just about monthly. Our next one will be on the 11th of May, when we'll be talking about trees. And in fact, I don't know if you know, many of you know, we have got University of Bristol Research, the Department of Biological Services, or Sciences, shall I say, have taken over an area of Hazeland and are conducting some quite interesting research on tree growth there. So we'll have Tommaso Yucco from that department, who's heading up that research, talking about it. And we'll just be giving you a general update on how things are at Hazeland, sort of about 9 months on since we bought it. So that's on the 11th of May, and hope you can join us then. If you do want to join up for the Avonese Trees newsletter, please do so through the website. You can just hook on through the contact us button, and we'll put you on our news email, which goes out every 2 to 3 weeks. But other than that, thank you very much for coming this evening, and thank you again to our speakers, and we hope to see you all again next month. Thank you.